All right, we now know what an atom sort of looks like, and now what we're going to be doing is finding homes for these electrons. We know the electrons live in orbitals, these different bubbles and different shapes of bubbles are what we're going to soon talk about. But what we're going to do is assign homes for the electrons and specific orbitals that they live in. And what this homes thing is called is electron configurations inside of the orbitals. It's covered in your textbook, page 153 to 162. So what we know so far is that electrons live in orbitals. Those are the bubbles that they live in. What we're going to look at today is I just want to present 3 rules to you on how we assign where the electrons go in each bubble. And when we do that, when we start to think about where electrons go, we can start to visualize what an atom really looks like. It doesn't look like these ring things. It kind of looks more like the picture on the right, which can seem confusing, but we'll get there. I want to bring to you where these electrons live, kind of like if you're going to college. You are going, I'm assuming, going to college here soon or going away somewhere. And when you go to college, they've got all these students, all these freshmen. They have to decide which dorm they're going to live in. How do we know what room they'll be in, what dorm, what roommates will they have? This is actually a picture of my college, Gustavus Adolphus. Little plug here. It's in Minnesota. It's a small liberal arts school, and it's fantastic. The pictures on the left are a couple of dorms that I stayed in. Complex and Euler and things like that, and these dorms are huge. Where do we put all these students? Kind of like atoms. There are electrons that live in these orbitals, but what orbitals do they live in? What bubble shape should they live in? That's what we're going to try and get into. So let's think about college. The college makes up rules where they're going to put the students based on what kind of students they are, maybe. Atoms have rules too, 3 rules which we're going to cover. So let's think about the college part. I'll get back to the rules. In college, you might have a rule that you're going to fill the lowest level first. Actually, I'm pretty sure they do that. If you go on to visit a college, they'll never take you up to like the 15th floor of the college. They'll just take you to the first level and let you look at that. It's actually the nicest one. If you live on the first floor, you have nicer rooms. Like in my college, I lived on the first floor freshman year, and we had doors on our closets. Everyone else didn't have doors on their closets. We had doors on the bathroom doors. It was nice. So something to think about. Maybe when you go to a college, ask to see the second floor. Just a thought. Anyway, if you're in college, they're going to fill the lowest floor first. Then they're going to fill all the rooms with 1 student, maybe. And after they do that, then they'll start doubling up the students. But let's fill the floor first, then double up. And then finally, they might want to pair students with different interests. Same interests, well, then you're going to see that person all the time. Too much of one thing is not always a good thing. So let's pair up the students with different interests. So I just kind of created 3 rules that maybe the colleges might go by. And these actually correspond to the 3 rules of the atom. The 3 rules are the Aufbau principle, the Hund's rule, and then number 3, the Pauli exclusion principle. The Aufbau principle says, let's fill the lowest level, energy level first. As the Hund's rule says, fill the rooms on a floor with 1 student first. Well, Hund's rule says, fill all the rooms or orbitals with 1 electron first, then double up. And the Pauli exclusion principle says, when you do have to double up, in this case electrons, do them with different interests. Interest in the electrons' case is sometimes electrons can spin clockwise, and the other time they spin counterclockwise, but electrons do spin. So when we put electrons in a room, we spin them one way, and then the next guy you add in has to spin the opposite way. Let me show you these rules in words. Aufbau principle. Electrons enter the lowest orbitals first. That's their ground state. It's still called ground state. Hund's rule, double them up only if you have to. The electrons are negative. They don't want to be in a negative one, but they will if they have to. And number 3, electrons in the same orbital have to have opposite spins. Pauli exclusion principle. So these are the 3 rules that we use in order to put electrons into their spaces, their orbitals. This idea of when you follow the 3 rules and you place the electrons in specific orbitals is called an electron configuration. How can we configure or place these electrons? And we're going to always arrange the electrons in the lowest energy level, the most stable way they possibly can. Tomorrow, bring these 3 rules with you. Put them in your head, keep them there, because we're going to be applying these 3 rules tomorrow in class together. Your Google form is found here. There'll be a link on the YouTube. Have a good night.